Myself, Dr. R Kesavulu, Associate Professor, Department of Physics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. So today I am going to discuss about the synthesis of Ln3 plus dope transparent glass ceramics for photonic applications. This is one of the important topic from the laser glass spectroscopy. So last and previous session was discussed on the optical spectroscopy of Ln3 plus dope silico-borate glasses for visible laser device applications. In that we discussed about the introduction, experimental methods or techniques, results and discussion, and the summary or conclusion of the Ln3 plus dope silico-borate glasses for visible laser device applications. So, outline of the today talk is on the synthesis of lanthanum 3 plus dope transparent glass ceramics for photonic applications. First, we have to discuss about the introduction, importance of glass ceramics, and how the synthesis of lanthanum 3 plus dope transparent glass ceramics is synthesized, and what are the important applications for the lanthanum 3 plus dope glass ceramics, and conclusion or summary of the transparent lanthanum dope glass ceramics. So, introduction first. So, what is the main motivation of the rare earth or lanthanide ions? So, this is the modern periodic table. In this periodic table, we are going to discuss about the lanthanum 3 plus ions. So, in this one, we have black elements. That is from atomic number from 58 to 71. These are the lanthanide ions or rare earth ions. In that, we are going to discuss about the different kind of rare earth ions. They are doped with the transparent glass ceramics. How these are useful for the photonic applications. That we are going to discuss in this presentation. Now, what is the importance of lanthanum 3 plus or rare earth ions? So, among the 14 elements, so 14 elements from the black elements, that is the lanthanide ions. In that electronic configuration, incomplete inner of 4f1 orbital, that is xenon 4f1 5s2 5p6, that is n equal to 1 to 13. So, these are the involved in the lanthanide ions or rare earth elements from starting from lanthanum to lutetium. So, these are the electronic configuration of the rare earth elements or lanthanide ions. What are the important optical properties for the lanthanide ions? Strong absorption and fluorescence. So, one of the important properties, strong absorption and fluorescence in the whenever the glasses doped with the rare earth elements. Next, a wide range of excitation level and emissions. So, these are the one of the important properties. This is UV visible and IR. So, we can scan the absorption spectra from UV ultraviolet to visible and far infrared region. So, we can cover both UV visible and IR region. So, what are the applications whenever lanthanum ions doped with glass ceramics? This is lasers, displays, sensor, lighting, and biomedical imaging, and etc. These are the important applications when rare earth ions or lanthanum ions doped with transparent glass ceramics. These are the applications of the glass ceramics. Next, main introduction of the glass ceramic materials. What is the main idea? This main idea of the glass ceramics is two-phase materials. That is, it exhibits the two-phase materials. That means one is crystalline, other one is amorphous. So initially it will be in amorphous nature. That is a glassy nature. Whenever that is we are giving heat treatment or nucleation process, we can amorphous material will be converted into the crystalline materials. That is the two-phase material is the glass ceramics. So what is the reason? So why we are preparing the glass ceramics? The main reason is if you see the amorphous material, the luminescence enhancement will be very less compared to glass ceramics. That is why purpose we are using for the glass ceramics, the enhancement of luminescence properties while doping with rare earth ions. That is increase of emission and decay time measurements. Whenever the enhancement will be happens, automatically emission intensity will be increasing compared to glass and glass ceramics, as well as lifetime decay time measurements also it will be enhancement from the parent glass material to glass ceramics. What are the requirements? Small crystal size, that is nano size particle will be available in the glass ceramics. That is incorporated, that is embedded into the glass material. We are creating a nano size crystalline materials in that glass material. That is why this called as a glass ceramics. Next, refractive index of the crystalline phase. That is depends on the refractive index of the crystalline phase and the percentage of non-crystalline embedded in a glassy material. How much percentage will be incorporated in the glassy material as nanocrystal percentage, how much? So if 100% of glass ceramics, so this is completely glass material. This how much percentage of the nanocrystal will be created inside the glass material. So that is very important. That is nanocrystals. That nanocrystals Based on nanocrystal only, the enhancement of luminescence property will be takes place. Automatically, emission intensity and lifetime decay means will be increasing from lower to higher. That means compared to parent glass to glass ceramics, it will be enhancement will be takes place. Since whenever the nanocrystal is formed in the glassy surface, glassy material inside the glassy material, so that's why automatically luminescence enhancement will be takes place. What are the matrices we are using for the this is especially chemical composition. So whenever glassy ceramics we are going to synthesize and fabricate, it should be oxyfluoride glasses with fluoride content should be there. That is lead fluoride, zinc fluoride, barium fluoride, sodium fluoride, strontium fluoride, yttrium fluoride, calcium fluoride, and etc. So whenever the fluoride content should be in the glass composition, automatically we can create the glass ceramics. That means nanoparticles we can synthesize because fluoride content will be reduce the photon energy from higher to lower value. Whenever a decrease in the photon energy will be low, automatically luminescence enhancement will be takes place because non-radiative decay will be very decreasing. Automatically enhancement will be takes place. That is the reason to synthesize the glass ceramics to enhancement the luminescence properties as well as lifetime measurements. Next, oxide based glasses. What kind of based glasses? It means silicon dioxide, yttrium oxide, P2O5, germanium oxide, hafnium oxide. These are the oxide glasses. These are the oxyfluoride glass. Whenever doped with the fluoride content, that is oxyfluoride glass. This oxide based glass. Others is fluoride and chalcogenide glasses. So these are the important materials to choose the chemical composition for the preparation of or synthesis or fabrication of the glass ceramic materials. This is the next. What are the methods to prepare the glass ceramics from glass to glass? First, so well-known technique is heat treatment by the nucleation process. By using the nucleation process, we can prepare the glass material to glass ceramics. Okay. Next, laser annealing. By using laser annealing also, we can create from glass to glass ceramics. Next, sol-gel technology. So these are the three important techniques. So in our study, we are used for the heat treatment process. In this method, we use it to study the or fabricate or synthesize the glass ceramics from glass material. So we are converting amorphous material to crystalline materials. What are the importance of glass ceramics in comparison to parent glass means pure glass material? So first exhibit better thermal stability. First property is to exhibit the better thermal stability. Next, second one is superior electrical insulations. Next, third one is higher mechanical strength. Next, fifth one is thermal expansion coefficient tunability. We can tune the thermal expansion coefficient while changing the chemical composition. Next, enhancement of luminescence property. This is the one of the unique and important application, the enhancement of luminescence property. So whenever glass ceramics will be synthesized or fabricated, automatically inside the glass material nanocrystalline will be formed. Automatically, whenever the nanocrystalline forms, automatically luminescence property will be enhancement will be takes place. So these are the important applications from the compared to glass ceramics to glass. Next, synthesis of lanthanum 3 plus dope transparent glass ceramics. How glass formation takes place. So this diagram for the specific volume temperature diagram. This is the volume versus temperature. So enthalpy and the volume you are taking, temperature in x-axis. So temperature versus enthalpy. That means enthalpy in the order of volume. So this, yes, see the slow temperature increasing. Okay, slow cooling, fast cooling. This Tm is melting temperature. So melting temperature of the glass material. Super cooled liquids. So fast cooling. So fast cooling means we can prepare the glass material. Slow cooling means we can prepare the crystalline materials. So crystal material will be formed while cooling this slowly. So when the temperature will be fixed, we can cool the from the 400 degrees, for example, 400 degrees centigrade to room temperature. It can take slowly cooling. At that time, we can form the nanocrystalline phase. That is glass having the short range order. So glasses having the short range order. In the case of crystalline having the long range order. So fast slow cooling takes place, we can form the crystalline material. So fast cooling we can prepare the glass materials. So these are the difference between amorphous materials and crystalline materials. Because crystalline materials having the long range order, glass materials having the short range order. These are the difference between crystals and amorphous. Amorphous is nothing but a glass. So this is the specific volume temperature diagram. In that we can see what is the glass transition temperature, crystalline temperature, and melting temperature. By using this one, we can prepare the glass formation. Next is the experimental technique, preparation of glasses. So generally we have glass preparation by using the conventional melt quenching technique. This is the one of the important traditional technique to prepare the amorphous materials or glassy materials. Initially we can take the chemical composition, the agate mortar. Then at that agate mortar we can press the powder from micro size to very fine powder, nano size. After that, taking the chemical composition, we put into the platinum crucible and cover with the platinum lid. Then we can keep into the electrical furnace at the melting temperature of 1400 degrees centigrade for 90 minutes duration. That means 1 hour 30 minutes. After melting the glass composition chemicals, we can pour into the preheated brass mold. So after brass mold, we can keep into the at annealing furnace at the temperature of 460 degrees annealing furnace at the temperature from 460 degrees centigrade for 5 hours duration. After that, we can cool down to the room temperature. Then we can do for the polishing and calibration technique we can do. But after cooling the room temperature, we are taking the glass pieces. These glass pieces we send to, first we have to prepare the glass to glass ceramics. After preparation of glass material, we can send to calibration analysis for DT analysis. That is very important. Differential thermal analysis. In that DT analysis, we can get the what is the glass transition temperature, what is the crystalline temperature, what is the melting temperature of the glass material. By using that values, we can do for the synthesis or fabrication of the glass ceramics. That how we are preparing the glass ceramics. See, bulk crystallization process. First, we initially what we are doing previous slide shows the how glass preparation takes place. The glass preparation we are doing the preparation technique is melting quenching technique. Then annealing process is very important. So annealing process only, that means nucleation or annealing. So we are giving some heat treatment to the glass material, prepared glass material. Then only we can get the glass ceramics. So see the temperature versus time. So how much here nucleation time? We are fixed from DT analysis, from DTA data only we are getting the differential thermal analysis data. In that measurements only we are observing the TG value. Where is the glass transition temperature? Next, TC1 or TC2, different crystalline temperature. So some glass material having only shows the one crystalline peak. Now some other glasses it will show the crystalline temperature C1 and C2 also. Next, TM, melting temperature of the glass material. So in this data we are getting from the DT analysis or DSC analysis, differential scanning calorimetry. So usually we are using DT analysis to study the glass ceramics. So by using the DT data, we are observing the TC1, TC2. By using that data only, we are doing the nucleation process or heat treatment process. See here. So synthesis of lanthanum 3 plus doped transparent glass ceramics. So we are using oxyfluoride transparent glass ceramics doped with different rare earth ions. So lanthanum is different from lanthanum to lutetium. So here the at least one phase should be there for glass material and one crystal phase should be there. One glass phase and one crystal phase. That means one glassy phase means glass transition temperature, other one is crystalline temperature. So crystalline temperature should be there at least one. So some cases 2, 3 also we can get crystal phase. So processed by the controlled nucleation and crystallization of the crystal phase in a precursor glass means parent glass. That is so optical properties of rare earth ions in fluoride ores and macroscopic properties of luminous Liegert glass. The macroscopic bulk properties. Glass means bulk property. That is we are going for microscopic. That means oxyfluoride nanocrystal size from macro to nano. So see here, this is the oxyfluoride transparent glass ceramics. In this, first you see this is the complete oxyfluoride glass matrix. This is complete big circle. This is the complete glassy nature. Inside small boxes that is a fluoride nanocrystals. In that fluoride nanocrystal, red one is red dots, red color. That is the rare earth elements. That is rare earth element ions. 85% of nanocrystals. The 80% of nanocrystals doped with 15% of glass matrix. So these are the how oxyfluoride transparent glass ceramics looks. So this is a TEM analysis in this data. Nanocrystal 25% of volume we are getting 10 to 25 nanometer size of the nanoparticles, nanocrystals. So this is the bulk property of the TEM analysis data. In this nanocrystal, In the volume of 25% of volume, we are getting the 10 to 25 nanometer size of the transparent nanocrystals will be we are observing by using the oxyfluoride transparent glass ceramics. See, this is a motivation or classes for photonics in solid state color displaces. So this is in science paper inside in 1996 they discovered the glass ceramics ZBLN glass. That is the ZBLN glass composition ZBLN glass doped with rare earth ions 0% doped of prismodium 3 plus and 0.5 mole percentage of erbium 3 plus and 0.5 mole percent of thulium 3 plus. So in this ZBN glass only they are doped with a different rare earth elements. Prismodium we can get red luminescence, enhancement of the red luminescence. In the erbium 3 plus doped glass ceramics we can get the green luminescence is the enhancement. In the thulium 3 plus doped ZBN glass we are getting blue emission. So these are the different rare ions doped with different glass ceramics. These are the applications. Next, IR, the infrared pumped visible lasers. These are we observed in these different papers. So in 701.5 nanometer laser pumping at 1.5 micrometer, we are observing the erbium 3 plus lithium yttrium fluoride plus sample that we are getting the 1.5 micrometer emission. Next, 551 nanometer laser pumping, we are getting 810 nanometer luminescence. Next, 450 nanometer, we are pumping 850 nanometer emission, we are getting. These are the different emissions studied in the glasses for photonic applications. Next, coming to the what is the upconversion process? The photo excitation at a certain wavelength in the near infrared followed by the luminescence at a shorter wavelength in visible is called the upconversion. Upconversion means we are giving the lower energy and we are getting the higher energy. That is upconversion. The down conversion means we are giving a higher energy and we are getting lower energy. So that is called down conversion. We are here. Upconversion is making one blue ion higher energy but to red luminescence. So making the one blue higher energy we are using two lower energies of red emissions. So here see this energy level diagram. This energy versus see here pumping luminescence, red luminescence. So red light. That means two photons we are pumping, but you are getting one higher energy visible region emission you are getting. So this is the upconversion IR to visible. So we are pumping with lower energy. That IR wavelength, infrared radiation wavelength should be in wavelength will be high. At the same time, energy will be low. But in output, we are getting the lower wavelength, but energy will be high. That is called upconversion. Upconversion is nothing but we are pumping with higher wavelength. That means lower energy. Output energy we are getting lower energy, but wavelength will be very low. So this is the very important things to study the upconversion mechanism. Next, coming to the fiber optic communication. So generally glasses and glass ceramics using for the fiber optic communications. So these are the different rare earth elements doped with different glass ceramic materials. See Nd3 plus doped glass ceramics, we are observing the green luminescence in the region of IR region. Next, if you see the volume 3 plus doped, we are getting the infrared emissions 1200 nanometer. If you see prismodium and neodymium and thulium, you are getting observing the wavelength in the near infrared region only. For erbium 3 plus, thulium 3 plus, volume 3 plus, we are getting the far infrared region. Generally, volume we are getting the almost 2100 nanometer emission. We are observing the volume 3 plus, and that is the mid infrared region. So mid infrared region, we are using the volume 3 plus and thulium 3 plus. For erbium 3 plus, prismodium 3 plus, we are getting the near infrared region, even Nd3 plus also. So these are the different rare earth doped different glass ceramics. These are the useful for the photonic applications, mainly for laser optical amplifiers, fiber optic communication. These are the optical amplifiers also they are using for the different rare earth doped glass ceramics. Since these are the enhancement or luminescence properties and quantum efficiency should be very high compared to glasses. That is why we are synthesizing and fabricating the glass ceramics to enhance the luminescence properties. That is the main reason to synthesize the lanthanum 3 plus dope transparent glass ceramics for photonic applications. This is the fiber optic communication is one of the important application in the photonics. Let's coming to the applications for the transparent glass ceramics. So this is the laser host furnace windows, the telescope mirrors. These are the different applications for using the transparent glass ceramics. See here these are the different glass ceramics. So these are the different glass ceramics they used for the furnace view port windows. These are the using for furnace view port windows. It's high temperature. Unable to see the how much temperature will be there. At that time we are using for the glass ceramics. That is furnace view port windows. That means you can in our naked eyes we can see the invisibly all the readings while using the glass ceramics is made by the glass ceramics only. The doped with the different rare earth elements. This is the one of the applications. Next, furnace windows, laser washed materials also they are using the glass ceramics, and telescope mirrors also using for the glass. That is one of the telescope mirror made by the zero dark glass ceramics. That means the zero dark is mainly lithium and sodium doped with the different rare earth elements. This is one of the important glass ceramics to use the telescope mirror. The telescope mirror is made by the one of the zero dark glass ceramic material only. These are the important applications in the transparent glass ceramics. That is very important. Transparent is very important. While preparing the glass to glass ceramics, we need to get the highly transparency. Sometime if we use the high temperature, it will be turbid, that is opaque material. So don't like that. So opaque materials also glass ceramics you can call, but in the case of transparent glass ceramics is very important to enhance the luminescence properties as well as optical luminescence as well as decay time measurements. So that is purpose we are used for the transparent glass ceramics. Next, some technological applications for the glass ceramics. In the electronic industry also they are using for the photo cinnamon circuit boards and capacitors, insulators, power packing. In power packing, these applications we are using for the lithium, aluminum, silicon oxide. These materials are used for the capacitor, insulation, power packing applications we are using. This kind of glass host material. Next, lithium and zinc oxide, lead oxide, silicon oxide are also using for the electronic industry. In military applications, what are the military applications means? Radomes, ceramic seals, and bomb trigger. This also made by the glass ceramics only. What kind of material chemical composition are choosing means magnesium oxide, aluminum oxide, titanium oxide, silicon dioxide. These are the one of the chemical composition for the prepare the glass ceramics in the use of military applications. Next, lithium oxide, aluminum oxide, silicon dioxide. These are also used to prepare the military applications for the glass ceramic material. Next, vacuum technology we are using for the ceramics to metal seal for the vacuum devices and energy sources like SOFC means solid oxide fuel cells applications also used for the glass ceramics. That glass ceramics is made by the zinc oxide, boron trioxide, silicon dioxide, one type of the host material. Next, other one is lithium oxide, zinc oxide, silicon dioxide, barium zinc silicate glass also using for the vacuum technology prepared by the glass ceramics. Next, domestic applications also. What are the domestic applications? Cooking ware. Because high temperature cooking ware is also used for the glass ceramics and tableware and heating surfaces. And heating surfaces also used for the different variety of glass ceramics that is made by the sodium oxide, aluminum oxide, silicon dioxide, one of the chemical composition. Other one is magnesium oxide, aluminum oxide, silicon dioxide. This is also one of the glass ceramic material to prepare the domestic applications we are using for the glass ceramics. Next, chemical industry. What kind of material you are using for the what are the applications means in chemical industry? Corrosion resistant tubing, pump impeller, telescope mirror blank. These are the made by the lithium oxide, calcium oxide, aluminum oxide, silicon dioxide. The other one is the lithium oxide, magnesium oxide, aluminum oxide, titanium oxide. These are the used for the chemical industry applications of the glass ceramic material. Next, biological applications. What are the biological applications? Means implants and implant sporting and dental materials also. Dental material applications also they are using for the different variety of glass ceramics. That glass ceramics is made by the sodium oxide, calcium oxide, potassium pentoxide, silicon dioxide. Other one, that is one of the host material. Next, other one is lithium oxide, calcium oxide, aluminum oxide, silicon dioxide. These are the some technological applications used for the transparent glass ceramics. These are the important applications in the electronics wise, military wise, next vacuum technology, next domestic and chemical industry and biological. These are the important applications wherever they use it in the glass ceramics for the different applications. Next, finally, conclusion. So glasses have advantage in good energy storage. So one of the good energy storage and high soluble in rare earth elements and can be shaped into any size of interest, including fiber also. We can prepare glass and glass ceramics like bulk to nanomaterials also. These trivalent rare earth elements are also substance of interest with their optical properties, which allow a variety of technological applications. So we discuss the different applications. So technology applications are used for the rare earth or lanthanum doped glass ceramics. Next, the rare earth doped materials have already been developed as sensor device applications, energy saving lighting devices, light converters, optical displays, optical fibers, amplifiers, and lasers. These are the different applications where the rare earth doped glass ceramics are used. Next, luminescence intensity of rare earth ions can be increased in the transparent glass ceramics and decrease in opaque glass ceramics. These are the one of the unique property in the rare earth doped glass ceramics. The luminescence, the enhancement of the luminescence properties that is increased. Next, the rare earth doped glasses and glass ceramics containing nanocrystals. Different kind of nanocrystals we can prepare. For example, strontium fluoride, calcium fluoride, barium fluoride, yttrium fluoride. These are the different nanocrystals. For solid state lasers applications, we can use for that crystals. Next, optoelectronic applications we can use in color display devices. And solar cell applications also we can use for the different lanthanum ion or rare earth elements doped with different host materials that we can prepare the glass material to glass ceramics. So glass ceramic containing nanocrystal is very important glass ceramics to enhance the luminescence properties as well as decay time measurements. These are the important conclusion or summary of the lanthanum 3+ dope transparent glass ceramics for photonic applications. Next, these are the references cited in this present work. So in this work, this Journal of Material Research in 2013. This is one of my paper. This is published in the 2013. In this paper, we published the erbium 3+ dope transparent glass ceramics. These are the used for the telecommunication applications, that optical fiber amplifier applications also we are used for the different erbium 3+ dope glass ceramics. This ceramic international in 2018 also published. This paper also we are doped with prismodium 3+ ions. Prismodium 3+ ions in this paper, erbium 3+ ions doped. So these are the important citation of this present synthesis of lanthanum 3+ doped transparent glass ceramics for photonic applications. So next class we can discuss the different rare earth doped glass ceramics. Next to be continued next session. Thank you. Once again, thank you.
Like, share and subscribe. Hit the bell icon for more updates.